Welcome to Spaceverse, your portal to cosmic adventures. Could the solution to life's ultimate question be hidden within this rock? A puzzling rock found by the NASA rover Perseverance on Mars provides more evidence that our red planet may have hosted intelligent life from beyond our solar system. The granite is decorated with dark bordered tracks that include iron and phosphorus. Fortunately, on Earth, microbes are usually the ones who make leopard spots. Has the search for Mars's microbes come to a close? From this one-of-a-kind finding, what inferences can be drawn? Are other planets in the solar system still harboring intelligent life? Surprisingly, the odds of this happening are quite low. The unexpected discovery of a massive underground water reservoir on Mars has led scientists to speculate that this red planet could be habitable. What is the connection between Albert Einstein's theory of relativity and a remarkable discovery on Mars? The answer, as surprising as it may seem, lies in Einstein's L, a pebble that has sent shockwaves through the scientific community. Now, before we get carried away with the fun of a clever twist on the name, let's focus on the real scientific discovery that has put Perseverance's findings at the forefront of astronomical discussions. What the NASA rover uncovered on Mars' surface a few months ago could very well be remembered as one of the most groundbreaking events in space exploration. The Perseverance rover, which has been diligently exploring the Jezero crater on Mars since February 18, 2021, has been capturing detailed images and data of the local topography and geological formations. The rover has covered a vast area of over 50 kilometers squared, which, long ago, was formed by a meteorite impact. This impact created the Jezero crater, which, up until about 3.8 billion years ago, was home to a fully developed crater lake with tributaries and deltas. Given its history, it's clear that the Jezero crater is no ordinary landing site for research. It's a treasure trove of scientific potential that could unlock answers to questions about the planet's past, including whether it ever harbored life. One of the key revelations about Mars that has long been beyond dispute is that it once had liquid water, likely cold, but still liquid, covering much of its surface. This makes Mars not just an intriguing place to study, but a compelling candidate in the search for extraterrestrial life. However, the question that continues to ignite debate among scientists is what happened to all that water over the course of billions of years. Has it simply vanished into space, or did it shift elsewhere on the planet? This question has stirred a great deal of controversy, as many proposed theories seem to contradict one another. Some suggest that Mars's atmosphere could have been stripped away, causing the water to evaporate, while others argue that the water may have retreated underground, hidden from our view. As it turns out, the answer may be closer to the latter theory. A new research study has emerged, providing compelling evidence to suggest that the water on Mars hasn't vanished into thin air at all. In fact, the data from Perseverance's ongoing exploration has led scientists to a shocking revelation. Mars water appears to have moved underground, potentially to vast aquifers or hidden reservoirs beneath the planet's surface. This discovery could be one of the most important breakthroughs in our understanding of Mars' history, as it opens up the possibility that liquid water still exists, albeit not in the open, frozen lakes we once imagined. But, of course, this is just the beginning of the findings, and there's still much to be learned. We will dive deeper into this exciting new research shortly. As part of its mission to examine the historic river delta in the Jezero crater, the Perseverance spacecraft is going to be responsible for both the collecting of material samples that will be brought back to Earth and the search for any indications of life that existed on Mars in the past. What's more, according to NASA's announcement in July, the rover may have found gold. The rover made a remarkable discovery when it came across a rock formation that had never been seen on Mars before. It was located at the northernmost point of the former river valley of Netta. The item that is needed is a rock that is approximately 1 meter in length and 60 centimeters in width. It has been given the name Chayava Falls by experts, and it is notable for the tail traces that it shows. This is already the case with the large white sulfate veins, which are located in the area where a much darker reddish substance is latent, indicating the presence of hematite. Because iron oxide is the only mineral that can be found on Mars, the fact that it is present at all is not particularly significant. But it is abundantly clear that this is not the case with regard to the countless minuscule dots that are embedded in the black hematite deposits. The minuscule specks, which appear to be unclean white spots with uneven shapes, are encircled by rings of black material, which is the rock that is the most intriguing, complicated, and possibly significant. What appears to be a mundane list of geological components to the average person is, in fact, a source of enormous pleasure for the professionals. This is due to the fact that additional testing have showed that the dark rings contain iron and phosphate. According to Ken Farley of the California Institute of Technology, Chayava Falls is the earliest evidence that may be considered irrefutable about the presence of biological stuff on Mars. Having said that, moreover, at the same time, Farley describes the item as the most enigmatic, complex, and potentially most important rock that Perseverance has examined throughout all of this period. The intriguing, and possibly elementary, notion that the colors of the numerous leopard spots symbolize chemical reactions that bacteria use for energy is the reason for this phenomenon. According to the findings of spectroscopic research, organic carbon molecules were found in the spots and the areas surrounding them. These molecules, along with phosphates and iron, are very comparable to residues that are often associated with microbiology processes on Earth. In particular, microorganisms that have preserved their fossil remains are a predominant source of spots that are found on terrestrial surfaces. In the subsurface, bacteria are responsible for the release of iron and phosphate as they break down iron oxide. According to what was mentioned earlier, Chayava Falls was located in a climate that was far more humid billions of years ago, which may have been ideal for the development of microbial life. Nevertheless, when seen in the opposite direction, what does the discovery of the rock signify? Perseverance has finally provided an answer to the age-old debate of whether or not the Earth is the only planet in the solar system that is capable of harboring life. The answer is a resounding no. There are other geochemical and abiotic processes that can make these similar compounds without the requirement for any form of life at all. Microbes are a common source for the organic molecules that originate on Earth. However, there are other processes that can produce these compounds. For instance, we have proof that such compounds are produced during volcanic eruptions. If the material that was found at Chayava Falls was similarly heated by lava, we would have to get rid of the possibility of small Martian life forms as quickly as possible. Indeed, the rock that was analyzed has even been found to contain a single grain of olivine, which is a mineral that is believed to be a solid component of magma. On the other hand, the fact that this area has a history of volcanism does not rule out the idea that bacteria are the ones responsible for the leopard marks. Chayava Falls, the ocean that is buried beneath the surface of Mars, and a great number of other mysteries continue to be unsolved to this day, and unfortunately, this is not likely to change anytime soon. The reason for this is that the researchers have pretty much exhausted all of their alternative methods of remote sensing. Despite their best efforts, many of Mars' secrets remain elusive. Consequently, the Perseverance rover has already bombarded the rock with X-rays and lasers, taking a wealth of photographs of it throughout the day and night from every conceivable viewing angle, hoping to capture clues that would help unlock its secrets. However, despite all of these sophisticated techniques, the data gathered so far hasn't been sufficient to provide definitive answers. It is necessary for the scientists to conduct a far more thorough investigation of the rock on Mars in order to uncover its mysteries. However, they will only be able to do so after they have brought relevant samples back to our blue globe. Only by analyzing actual Martian material on Earth will they have the means to gain deeper insights into the composition and history of the rock. The transport of these samples back to Earth is crucial, as it will allow scientists to use a broader range of investigative tools that are not available on Mars. On the other hand, when the day of the return transport arrives, specialists will have access to highly accurate and advanced analytical instruments, which will enable them to determine with greater certainty whether the artifacts that we are observing are the result of volcanic eruptions, the preserved labor of Martian bacteria, or something else entirely. With these state-of-the-art instruments, they will be able to study the samples in ways that are impossible with the current technology on Mars. It may be hard to believe, but there is a possibility that Mars is currently experiencing volcanic activity. This possibility, while still speculative, is one of the most fascinating aspects of the planet's ongoing mystery. If Mars is indeed undergoing volcanic eruptions, it could have profound implications for the planet's geological activity and even its potential to support life in the past or present. This remains one of the great unknowns, but as we continue to explore and gather more information, we may one day uncover the truth about Mars' hidden forces. The seismic data that was gathered by the Mars InSight mission gives compelling evidence that the red planet most likely still has volcanic chambers. However, this is not the only or perhaps the most exciting secret that Mars InSight has discovered beneath the surface of our neighboring planet. According to the data obtained by the probe, a large reservoir of liquid water is hidden at a depth of 11 kilometers that is hidden from view. The word large is synonymous with massive. It is estimated by specialists that there is sufficient water below to form an ocean that is between 1 and 2 kilometers deep, which would encompass the entire planet. As was said briefly earlier, One of the most significant mysteries that surrounds the ongoing research on Mars is the question of where the water that formerly existed on the red planet has vanished to. Between approximately 3 billion years ago and the present day, there were rivers, lakes, and a massive ocean all present. A drastic change in the environment of Mars brought an end to the planet's habitable chapter, which resulted in the disappearance of water from the reddish shimmering surface of the planet. Numerous experts have, for a considerable length of time, been of the opinion that the bulk of the water that was present in the ancient Martian sea simply disappeared into space. This is due to the fact that the polar ice caps and the water ice at moderate latitudes are not sufficient to store the total quantity of water. During the time when there was no longer a requirement for a magnetic field, the solar wind had the capability of effortlessly lifting sections of the atmosphere, together with the water that had been cooled, into space. A research group led by Vashon Wright at the University of California, San Diego, has proposed a hypothesis that Mars's water didn't vanish, but rather infiltrated and became trapped within the planet's crust. This theory suggests that water migration into the crust could explain why Mars appears so dry today, despite evidence that liquid water once existed on its surface. To test this, the researchers analyzed seismic data from NASA's Mars InSight mission, which has been monitoring seismic activity on Mars from 2018 to 2022. The data revealed that, although the Martian crust is generally dry, a layer extending to about 300 meters deep contains unexpectedly high amounts of trapped water. This suggests that water may have migrated underground over millions of years, becoming locked in mineral deposits or hidden reservoirs. The findings challenge the idea that Mars water has completely disappeared and raise the possibility that water still exists beneath the surface. This discovery opens up new questions about the planet's habitability, suggesting that hidden water could support life or offer insights into Mars' ancient environment. It also implies that Mars may not be as lifeless as previously thought, with subsurface water possibly playing a crucial role in sustaining microbial life. Further exploration of these water reserves may reveal more about the planet's history and its potential to harbor life. If confirmed, this trapped water could also serve as a vital resource for future human missions to Mars, providing both drinking water and the potential for oxygen and hydrogen production. Such discoveries could revolutionize plans for long-term exploration and colonization, reducing the need to transport large quantities of resources from Earth. Additionally, understanding how water became sequestered in the Martian crust could offer valuable insights into the geological processes that shape the planet, potentially shedding light on similar processes on Earth and other rocky planets in our solar system. Would it be possible for life to continue to exist on Mars? In the first place, contrary to initial expectations, the investigations revealed that the Martian intermediate crust is not as solid and compact as previously thought. Instead, it is characterized by numerous holes and pores, which may play a significant role in the planet's ability to retain water. The data from seismic activity, on the other hand, suggests that liquid water is present within these minuscule cracks and fissures. To be more specific, it is estimated that these underground storage facilities account for around 177% of the rock mass in that region. To restate, the largest amount of water that can be found in the center crust of the planet provides the most satisfactory explanation for the evidence. For the sake of clarity, let me also mention that all of this is premised on the fact that the findings of the research are representative of the entire planet and not simply the surface of Mars. The intriguing thing is that if this is the case, then the red planet might have a large subsurface water reservoir concealed in its porous rock. This is the part that makes the situation interesting. The question of whether or not it is conceivable to discover extraterrestrial life forms in the water that is found beneath the surface of Mars is another intriguing one. Taking into consideration the fact that the volume of water that is expected to be present in this scenario is sufficient to submerge the entire planet to a depth of between 1 and 2 kilometers, this is a particularly intriguing proposition. In response to this confusing problem, the experts have proposed a solution that is not only easy but also intriguing. Why not? We must not lose sight of the reality that many terrestrial animals have evolved to flourish in the face of seemingly insurmountable barriers, such as the absence of light and oxygen. This is something that we must not overlook. In light of the fact that water is necessary for life as we know it, I don't see any reason why the underground reservoir on Mars shouldn't also be a life-friendly environment, says Michael Monga, a co-author from the University of Berkeley who was involved in the study. There is a potential habitat that could support life on Mars, despite the fact that there have been no traces of life discovered on Mars up until this point. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.